All right, today we are embarking on Chapter 8. So you might have be thinking like, we just got done with Chapter 4. We are skipping around a little bit. I want to get this material in before Christmas. So do the rest of the Algebra 1 Advanced teachers. So we're jumping around. All right, we will come back to 5 later. Going for Chapter 8. All right. So Chapter 8 is all about graphs. So we are going to start looking at equations now that have 2 variables. They have x's and they have y's. When you are looking at an ordered pair, this is the x value, this is the y value. State whether each ordered pair is a solution to the given equation. So we are going to put the x value in for the x, the y value in for the y, do the math. If it's true, it's a solution. If it's not true, it's not. So when I put the 2 in for the x, I have 7 times 2 minus 2 times 7 in for the y equals 0. Now, what is 7 times 2? 14. What is 2 times 7? Also 14. What is 14 minus 14?
0.
So 0 equals 0. Is that a solution? Yes. So if the ordered pair makes the equation a true statement, it is a solution. These 2 numbers are not the only x's and y's that work. So they're not the only solution, but it is a solution that makes the equation true. Any questions? All right, so here's our next ordered pair. Which one's the x? 3. Which one's the y? 4. So rewrite the original equation. Instead of x, I put a 3. Instead of y, I put a 4. Number next to a variable means multiply, so I rewrite this just with multiplication. What is 7 times 3?
21.
What is 2 times 4?
8.
8. That is false, right? 21 minus 8 is definitely not going to be 0. So is this a solution? No. All right, so here's part B. See how it's A and B now? This one's going to be A, this one's going to be B. These are always in alphabetical order. So we're going to call that A. We're going to call that B. Take the A and the B out, put the -1/2 and the -5 in. Do the math. If it's true, we say yes. If it's not true, we say no. What is 2 times -1/2? -1 plus 15, is that 16? It is not. That'd be 14 equals 16, which is false, so this would be a no. I believe so. Yes! All right, once again, the first one is A, the second one is B. So take A out, put -5/2 in. Take B out, put -7 in. That's going to be -5 plus 21. Is that true?
Yeah.
That is true. So is that a solution? Yes, it is. So next we're going to actually look at the graph. So this is what we call this the coordinate plane. This is what it looks like. And the origin is where the x-axis and the y-axis intercept. And this is the point 0, 0. Okay, so you go side to side 0, up and down 0 when you graph these, right? X is 0, y is 0, you're right at the beginning. Okay? So the definition is the intersection of the x and the y. Any questions? So that's the origin. All right, some more definitions. The x-axis is the horizontal number line. So this guy right here. The y-axis is the vertical number line, so this guy right here. And then we already talked about this when we were plugging these in to check the solutions. The first number is the x. The second number is the y. I just always remember alphabetical order, right? X's come before y's. So the first number is our x coordinate. The second number is our y coordinate. So the first number tells us what to do on the x-axis, side to side. The second number tells us what to do on the y-axis, which is up and down. So do you see how the graph is broken into 4 parts? Those are called quadrants, okay? So when you're over here, this is called the first quadrant, and we label them with Roman numerals. And then it's kind of counterintuitive, I always thought. You go this way, okay? You go counterclockwise. So this is the second quadrant, third quadrant, fourth quadrant.
I already forgot this from
What?
last year.
You already forgot this from last year? Well, here's your chance to redeem yourself, okay? So anytime we're talking about what quadrant it's in, I just label them 1, 2, 3, 4 right off the bat, just so I don't get confused. We're going to graph these ordered pairs. So remember, the first number is what you do left and right. The second number is what you do up and down. So to graph 2, 3, I go right 2, 1, 2, then I go up 3, 1, 2, 3, and I put a point. Now, whenever it's written like this and it has a capital letter next to it, you need to label the point with that capital letter. Okay, this is point A. To graph point B, we will start at the origin again. We will go left 1, 2, 3, 4, up 1. And I will label that with a B. To graph 2, 0, I go right 2, I go up and down nothing. To graph negative 5, negative 1, I will go left 5, 1, 2, 3, 4, 5. I will go down 1. I will label that one with a D. How will I graph point E? Yes, sir.
Right 3, down 6.
1, 2, 3. 1, 2, 3, 4, 5, 6. And I'll label that with an E. All right, the zeros always throw people off. Just remember, that's how many are going in that direction. So if the 0 is first, you go side to side 0. So you're kind of like, oh, I'm stuck. And then you go down 4. Label that one with an F. Now it's the same process in reverse. So I am going to find the point Q, and I'm going to figure out how I got there. So you'd have to go left how many? So left 4, so negative 4, and then we go up 3. So the point would be negative 4, comma 3. Put parentheses around it, or you are not getting full credit. All right, now what quadrant is it in? 2, because we go 1, 2, 3, 4.
Do we have to use Roman?
You have to use Roman numerals. Yes. All right, how would I get to point R? Right 2, up 2. So what's the ordered pair? 2, 2. With comma in the middle, parentheses around it. What quadrant is point R in? 1. What is the ordered pair for S? 0, 0. And that is not in a quadrant. If you put origin, that would be fine.
Would we get counted off on the test if we put origin for
Nope.
You need to count off the XY intercept.
That's not the XY intercept.
You mean slope intercept?
X and Y intercept are different. Something different. It's where the x-axis intersects the y-axis, but that's not the xy intercept. I mean, no, don't put that. Okay. T, how would you get there?
Left 4 down 4.
Left 4 down 2. So that'd be what ordered pair?
Negative 4,
-4, -2. Boys, you have a question? No? All right, what quadrant is T in? 3. U, what's the ordered pair?
2,
-1.
2, -1. What quadrant is U in?
4.
The 4th. Good. And don't put like 4 lines. It's IV, Roman numerals, okay? And then V is 4, 4, and that is in quadrant 1. Very good. All right, your notes have a little more than mine do, so we'll just read through them. It says, example 3, graph the following equation using a table. So, to make a table, we want to get y by itself. Then we want to find 3 ordered pairs that are solutions to the equation. Graph the 3 points. Connect the dots to make a line. Your line must cross both the x-axis and the y-axis unless it's a horizontal or vertical line, and you must have arrows on both ends. Okay? So, how would I get y by itself here?
Subtract 2. I mean x.
Subtract x. Okay, I'm going to write this in a weird way that will make sense in a couple days. Okay? I am going to always put the x next to the equal sign. It's just going to make more sense later instead of doing it one way than doing it a different way. If you put 2 minus x already, that's fine. Just write it one more time. Y equals, I'm going to make it -x plus 2. The 2 is positive, the x is negative because I subtracted it. I want the x next to the equal sign. It's just something that I'm used to, and I'm going to go with it, and you're going to go with it too. All right, now we're going to make what's called an XY T-chart. Have you seen these? Okay, this is where you get all the power, okay? You get to pick the 3 x points we put in. I'm always going to put in 0, 1, 2 because they're the easiest ones, okay? 0, 1, 2. I am going to plug those numbers in one at a time for the x. I'm going to do the math to find the y. So my first one will y equals -0 plus 2. Is there such a thing as -0?
No.
No, it's just 0 plus 2, which is 2. So over on my graph, I will graph the point 0, 2. Side to side 0, up 2, put a point. Now I'm going to plug 1 in for the x. So y equals -1 plus 2, which is y equals 1. So now I have the point 1, 1. And finally, I will plug in a 2. So y equals -2 plus 2, which is 0. So I have the point 2, 0. So write 2 up and down 0. Now, if you don't get a line here, you have made a mistake. So you are going to use the side of your ID. It does.
Oh my God.
So you are going to line up those 3 dots with the side of your ID. If you have a temp, find something else, like another piece of paper or a note card. Line up the 3 points. You have to cross the x-axis and the y-axis. Here we already did. If not, you just keep on going with that line. And all of these have arrows on the ends. Now, what this represents are all the XY points that make this true. So you could even go like way out here and pick this point. This is the point 1, 2, 3, 4, 5. This is the point 6, -4. If I plug in 6, -4 to the original equation, It's true. See that? Okay? All the ordered pairs that fall on that line are true. That's why you put arrows on the end, because the line keeps going. The solutions keep going. The solutions keep going. What?
Wouldn't that be 6 minus 4?
Yes, which is 2. That's why I said it was true. Yep. All right. Any questions on what we're doing, why we're doing it, how to do it? Anything at all? All right. So, how do I solve for y here? You don't, okay? But I can still make a t-chart.
It's up and down.
The only problem is every single x value is 3. Give me 3 y values.
1, 2, 3.
1, 2, 3. That works. So I'm going to graph those 3 points. 1, 2, 3, 1. 1, 2, 3, 2. All right. This is a special line. What's it going to look like?
Up and down.
Up and down. Good.
For some reason, X goes up and down.
Now, the way I remember these, x equals and y equals lines, when there's only one variable and not the other, that's the axis that it goes through. So if it's an x equals line, it's going to go through the x-axis at 3. So if you drew it this way, it would be the x-axis. We don't want to be the x-axis. We want to go through the x-axis. Okay? That's how I keep these straight. Which one's up and down, which one's side to side. Can you all see that? I'm sorry, it's kind of... Let me make it a little thicker. Whoa, it's going to be real. There you go. You can all see it now. Boom.
Where's the
The dots are gone. All right, any questions? All right, here's our next one. So again, our strategy is going to be to get y by itself and then to find 3 ordered pairs. All right, how will I get the y by itself here? Yes. Subtract 2x. Don't forget that negative is still with the 3, so negative 3y equals, I'm going to sneak it right up in there. Remember, I want the x. And then plus 3 or minus 3? Plus. The 3 is still positive. All right, here's the tricky part. If you divide by negative 3, you are dividing each of the terms on the right side by negative 3. Did everybody catch that? Yeah. So, those go away. You have just the y. Negative over a negative becomes a positive, and I'm going to leave this 2/3. Then I have the x. What's plus 3 divided by negative 3?
Minus 1.
It's going to be a minus 1. Good. All right. That was the first challenging step on this one. What are your questions? Okay. I am going to be very strategic about what I plug in here. I'm going to do it up here. Because I don't want to graph a bunch of gross fractions. Okay? 0 is going to work. Now, what are some other numbers that would give us whole numbers when we multiplied by 2/3? 3 would work.
6.
And 6 would work. Now, do you have to do this? No. Do I want you to do it? Yes. Because I don't want to graph like 2/3 of something or on this tiny little thing. Okay? So I want whole number ordered pairs. So I picked numbers that were divisible by 3 so that the fraction would go away. Remember, you have all the power in the x column. You pick the easy ones. Don't make more work for yourself. Okay? So, let's start it off. Y equals 2/3 times 0. Well, that's just 0. And what's 0 minus 1? -1. So we graph that guy. Side to side, 0, down 1. All right, now I chose 3 on purpose because what would that give me on my first term? 2, right? The 3's go away, you just have a 2. Minus 1 is 1. So now I am at 1, 2, 3, 1. And then 2/3 times 6 minus 1. That'd be 2 times 2, which is 4 minus 1, which is 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3. All right, questions on how I got those, why I picked those numbers, what the heck I'm talking about. All right, something super straight. Connect them. Arrows on the ends. Questions? Oh, indeed. At least it's Tuesday already.
We got one more left.
One more left. Let's do it. Oh, this one's not bad at all.
Okay.
All right. How do I start? Subtract 3x. So I have y equals what?
-3x plus 2.
Negative 3x plus 2. Boom. Questions? All right. Now what? X, Y. What do you guys want to plug in this time?
0, 1, 2.
0, 1, 2. Let's keep it easy. So y equals -3 times 0 plus 2. What does that give me?
2.
2. So side to side 0 up 2, and I put a point. Then I will plug in 1.
-1.
So that's -3 plus 2, which is -1. So write 1 down 1. And when I plug in 2, -3 times 2 plus 2. What's -3 times 2?
-6.
Plus 2 is
4.
-4. Hold on. Before I do that, I'm going to use you as an example. So he accidentally said 4. So let's pretend you got 4.
You can still do that.
So if I got positive 4, you don't need to write this down. I would be right here. Why is that not going to work? It's not a line. If you are not getting a line, you are making a mistake. This is not a connect the dots art project, okay? You have messed up. And if there's only 3 points, it's hard to tell which one is the mistake, so you might just want to redo all of them. Or pick a 4th point, find that, and then you can kind of see what the trend is and which one's just not fitting in right. But yes, if we do -4, which is the correct answer, do you see how now it is definitely a line? So that's a good way to check yourself is, are you actually graphing a line, or are you graphing more like a cluster?
Couldn't you change the x to -2?
All right. All equations that have no powers other than 1 are called linear equations. Why do you think they're called linear equations? Because they make lines. That's what we just got done discussing. If yours does not make a line,
It's not linear.
and you don't have an exponent that's something other than a 1, you've made some sort of a big mistake, okay? When you have x's and y's, no exponents, you should be getting lines. Questions? All right, what did we learn about today? Graphing. If you want to be fancy, you could say graphing linear equations. All right, here comes your homework.